Hello students, in today's class we are going to learn how to divide a given line segment in a given ratio. So let's start with this question here. Divide a line segment AB in the ratio 3:2. So roughly we've been given a line segment AB. So we can take any line segment AB. We haven't been given any measurement, so we'll take a line segment AB of any measure. Now we've been asked to divide AB in the ratio 3:2. That means we need to locate a point on AB. Any point on AB, let the point be C. Now the position of C should be such that the ratio of AC is to the remaining part, that is BC. AC is to CB or AC is to BC is equal to 3:2. That means AC stands for 3 parts and BC stands for 2 parts of the whole line segment AB. Now this is the requirement here. So let's start the construction by first starting with the line segment AB of any measure. So here's the line segment AB, and in case of questions where the measure of the line segment has been given, so in those cases we'll be following the instruction as per the question. So in this case, because we do not have any measure, so I've drawn a line segment of any measure. Next, we need to divide it in the ratio 3:2. So what we'll do is we'll first start by drawing a ray AX such that it makes an acute angle with the given line segment AB. So here's a ray AX, and the only thing we need to be careful is that the angle that it makes, if this is X, then the angle BAX must be an acute angle. And now since the ratio is 3:2, so some of the parts or some of the ratios give me 3 plus 2 is equal to 5. Now we will be dividing the ray AX into 5 equal parts of any convenient measure. And it's 5 parts because 3 plus 2 gives me 5. Whatever the ratio has been asked in the question, we add the two numbers and the sum is what tells us how many parts the ray has to be divided into. Now the measure of each part is totally dependent on what is convenient for you to construct. So this is first part. Second part, third part, fourth and fifth. So we've divided AX into 5 equal parts and we'll name them for our reference. Let the first part be A1, A2, this is A3, A4 and A5. So after successfully dividing into 5 equal parts, we'll now go back to our required ratio. This is 3:2. So first part is made up of 3 parts. Now that means the first part 1, 2 and 3. This here signifies the end of the 3 parts and A5 here signifies the last part. So the next step we'll be following is we are going to join A5 to the point B. So we are joining A5 to B here. And since we want the division at the end of the third part, so that the position where we want the division will be A3 for us. So A3 is the point where we want the division to happen, so that we have 3 parts and 2 parts separately. So the next step will be drawing a line parallel to the line BA5 at A3. So at A3 we are going to draw a line parallel, and to draw a parallel line we first start by drawing an arc of any convenient measure at the point A3. So here's an arc of any measure. You can also draw a smaller arc. The reason I'm drawing a bigger arc is only for clarity's sake. So I've drawn 2 arcs of the same measure, once with A3 as the center and the second time with A5 as the center. Now we need to measure this angle and reproduce the same angle on this side of the arc so that we have the corresponding angles equal to each other. Now let's measure this angle here. So the arc measure is this, and without disturbing, I am going to cut the same arc measure by placing the compass needle at the point where the arc cuts the ray AX. Now this is the line. So the next step would be joining the point of intersection of the arcs to the point A3. A3 is where we wanted the parallel lines. So this line is parallel to that. Let's mark this as the point C. CA3 is parallel to BA5, and the reason it's parallel is by construction we have constructed an angle here. By angle I mean the angle AA3C, this angle same as this angle, and they are a pair of corresponding angles, so that makes the lines BA5 and CA3 parallel to each other. Now that we have the two lines parallel to each other, we have exactly what we want in our construction here. Now how is it exactly what we want? Let's go through this again. In this, if we consider the triangle AA5B, so in triangle AA5B, we'll justify our construction now. We have constructed CA3 parallel to BA5, and this is by construction. Now that implies, we can use basic proportionality theorem to talk about the ratios. Now that means the ratio of AA3 by A3A5. So the first part is AA3 divided by A3A5. A3A5 is equal to AC by CB, and this result we know by the basic proportionality theorem. Now since this is equal, but we know how many parts is AA3. Now A3 is equal to 1, 2 and 3 parts. So AA3 here is 3 parts and A3A5 is equal to 2 parts. That implies we have AC by CB is equal to 3 by 2. Or if we can write this in the form of a ratio, so this becomes AC is to CB is equal to 3 is to 2. If AC is to CB is equal to 3 is to 2, that's exactly the ratio that we wanted in the question. Now let's go back to the question. Divide a line segment AB in the ratio 3 is to 2. That means C is the point which is dividing the line segment AB in the ratio 3 is to 2. So that is the conclusion of our construction. C is the point that divides AB in the ratio 3 is to 2. Let's go through the steps of construction. So we were given the line segment AB. So we started by constructing a ray AX such that angle BAX is an acute angle. And then we cut 5 equal parts along the ray AX, and the length of each part depends totally on our convenience. So we can take an arc measure of any convenient length, but we need to remember that all parts must be equal in length. And the parts are A1, A2, A3, A4 and A5. The next step is to join BA5 and then construct a line CA3 in such a manner that CA3 is parallel to BA5. Then we arrive upon C, which is the required point that divides the line segment AB in the required ratio, that is 3 is to 2 in this question.